Hello, ladies and gentlemen. I am Hadi Esmailnejad from Sahand University of Technology, Iran, and my talk is about connection geometry evaluation in freeform space structures. In recent decades, a new generation of space structures called freeform space structures has been developed. In freeforms, each connection may have its own specific geometry, so a great deal of variety and complexity of jointing geometry could be considered. The connection geometry can be obtained by calculating the connection angles. Therefore, the main purpose of this paper is to calculate these angles and study the range of their variations. In freeform single-layer lattice space structures, internal forces in members can vary from axial forces to large bending moments. Therefore, members commonly have rectangular cross-sections in these structures. Thus, the connection angles can be defined: U as horizontal angle, V as vertical angle, W as twist angle. The twist angle is of great importance from constructional point of view. The main step for connection angles calculation is the manipulation of the member vectors and nodal vectors. Given that in design and construction process, designers are involved with a discrete structure instead of a continuous initial freeform surface. Therefore, panel vectors can obtain with cross product of two members' axis vectors of a mesh. The member vectors and the nodal vector are also obtained by averaging technique. The connection angles are calculated and evaluated through MATLAB computer programming software for freeform space structures. Using this algorithm, in this paper, verification will be provided with AutoCAD software. Although three types of meshes used in single-layer lattice shell structures are studied: triangular meshes, planar quad meshes, warped quad meshes. In general, in freeforms, quadrangular meshes are warped. Mesh warping creates complexity in calculation of panel vectors. For connection geometry evaluation, the configuration of two lattice freeform space structures have been selected for the available forms in the Formian K gallery. First, the freeform dome with triangular meshes. This table shows the maximum, minimum, average, and standard deviation of these angles all over our connections. The bottom table also shows that about 2.10% of the connections have twist angle more than 4 degrees, with the highest angle of 6.28 degrees. As shown in the figure, the node vector in node 77 has large offset. This node can be considered as a critical node in terms of maximum twist angle. In addition, due to the high rate of change in slope of the form and in the network line, as shown in the figures, the nodes on this line have large value of twist angles. In this figure, the histogram diagram of the connection angles throughout the structure are shown. It can be seen that these angles change in a relatively small range. Second, this freeform single-layer grid space structure has been selected for connection geometry evaluation with quadrangular meshes. Also, according to studies in this paper, this node has the high twist angles in its connections in this structure. This table provides information on the range of variation of angles in this structure, and groups of absolute values for twist angle in each internal connection have been shown in bottom table. Due to the low rate of change in slope of form in this configuration, the twist angles are less than 2.26 degrees all over its connections. Also, the histogram diagram of connection angles throughout this space structure are shown. Conclusions. The mentioned algorithm is able to automatically and accurately calculate the connection angles, while the calculating these angles without programming in other CAD software is time-consuming and difficult. 2. A high rate of change in slope of a form and subsequently meshing of a structure, such as corners and cusps, creates nodes with high twist angles in its connections that cause a cost issue. 3. In freeform lattice space structures, the connection angles are different from one mesh to another, but they change in a relatively small range. These results are crucial in manufacturing new jointing systems or utilization of existing systems for these structures, and also highlight the importance of developing knowledge in the field of fabrication-aware configuration processing for architects and engineers. Thank you for your attention.